Dear students, I welcome all of you for this session on Internet of Things. In this session, let me study about programming Raspberry Pi with Python. First, let us have a look at agenda of this session. First, I will be introducing you the basics of programming Raspberry Pi with Python. Means I'll tell you how we can program Raspberry Pi using Python language. Next, let us have a look at some simple Python programs on Raspberry Pi computer, like printing some message or writing some message to a terminal. Next, we'll see how to add two numbers. Next, suppose I want to know the IP address of the Raspberry Pi computer, how we can program. Next, let me see how we can program Raspberry Pi computer to print Fibonacci numbers. Next, we'll display a calendar of a given month of the year. Later, let us see some interfacing programs on Raspberry Pi. We'll see how we can interface some external devices. Okay, say an LED, light emitting diode, say buzzer, and passive infrared sensor, which is a motion sensor to Raspberry Pi computer. Now, let us have a look at programming Raspberry Pi with Python. See, Raspberry Pi is a Linux based operating system. Okay, and it supports Python programming language. I repeat, Raspberry Pi is a Linux based operating system and supports Python programming language. Hence, all Python programs that you run on some other computer can also run on Raspberry Pi computer. But the GPIO pins, what you can able to find on Raspberry Pi computer, makes Raspberry Pi a useful device. An endpoint in Internet of Things projects. I repeat, the GPIO pins on Raspberry Pi makes it useful device endpoint in Internet of Things. Through GPIO pins, Raspberry Pi computer can be interfaced with variety of sensors, actuators, and also we can interface to outside world or other devices using SPI interfaces, I2C interfaces, and serial interfaces. These sensors, actuators, which interface to Raspberry Pi through GPIO pins, can receive input from the Raspberry Pi. They can process that input and they can take action, say sending data to server, sending an email, triggering a relay switch. So This is about a brief introduction to programming Raspberry Pi with Python. So let me recapture what I said. It's a Raspberry Pi, that is Raspbian, is a Linux based operating system and supports Python. All Python programs that you run on some other laptops or some other desktops, you can run on Raspbian too. And the GPU pins on Raspberry Pi computer makes Raspberry Pi computer as a useful device, that is an endpoint in Internet of Things. We can interface sensors, actuators to Raspberry Pi through this GPIO pins and also through SPI I2C serial interfaces. The sensors actuators which are interfaced to Raspberry Pi can receive input from Raspberry Pi and can process that input. After processing, they can take actions such as sending data to server, sending an email, triggering a relay switch. Now, let us have a look at some simple Python programs. Okay, as usual, when you start to learn any programming language, the first program we will start with is an Hello World program. Similarly, here we'll start with an Hello World program. Okay, the first and foremost thing we require components, and what are they? The first one is the Raspberry Pi board. The next SD card to which Raspbian is loaded. Next monitor. Next HDMI cable to interface monitor and Raspberry Pi board. Next USB keyboard, USB mouse and power supply to turn on Raspberry Pi computer. So some key points you need to remember. First, you get Raspberry Pi board. Next, have the SD card loaded with Raspbian. Insert that SD card into SD card slot. Next, get some display, that is monitor, and interface monitor to Raspberry Pi computer, I mean Raspberry Pi board through HDMI cable. Now plug in the USB keyboard to use it through USB port. Plug in the USB mouse to the USB port. Plug in power cable. Now turn on the adapter. Now once the power supply is given to Raspberry Pi board, Raspbian is getting loaded. I mean the operating system gets loaded. Now you will be prompted to enter username. Just enter default username Pi. And I said for default username Pi, the password is Raspberry. Just submit. A Raspberry Pi desktop will be appearing. Now on the taskbar there's an icon named terminal. Just double click on it. Now terminal will get loaded. Okay. Now in terminal, when you execute command pwd, I mean print working directory. Okay, it shows the current directory in which you reside, and that is usually the home directory. Now, let us create one directory in a desktop. Okay, and let me save all my Python programs in that directory. So first I need to move from my home directory to desktop. For this, use command cd change desktop. That is cd desktop. Now you will be under desktop directory. Now under desktop directory, let me create one directory named python underscore code. For this, I need to make use command mkdir. So execute mkdir python underscore code. Now a new directory named python underscore code will be created under desktop. Now move to python underscore code directory. Executing command cd python underscore code. Now in this python underscore code, let me create a new file named helloworld.py. Okay, helloworld.py. Now, and in this file, I need to write my Python code. And in this case, let me show you the code. See, when you look at the code section, okay, there's a massive statement print. And for the statement print, there's an argument hello world. Okay, so what actually print statement? Print statement on execution writes anything that has passed as an argument to a terminal. Got it? So this code you need to write in helloworld.py. You save this file. Now, after saving the file, run the code, Python code, sudo python helloworld.py. You will see the message hello world to be printed on the screen, on the console. So to print hello world, the statement is print. And the second code here, it shows you how to add two numbers. See here, I have used two variables a and b initialized with the two floating point values 1.2 and 5.3. Now, as usual, plus is an addition, use that operator, and later the result will be in variable sum. Then make use of print statement. In the next program, to find IP address, okay, we need to import two packages, urlib re. Got it? So then we can get the IP address of the computer by accessing the website http://checkip.dyndns.org. The IP address is assigned to a variable URL. Using print statement, I can print the URL, that is IP address. Now, here you can see a Python code to print Fibonacci numbers. Until the Fibonacci number we print is less than 200. The first two Fibonacci numbers, that is 0 and 1, are initialized to variables a and b. A and b. Then we are using the code as you can see on the slide for printing Fibonacci series. Next, to display calendar of a given month of a year, we need to import package named calendar. We are going to use two variables yy to store the year, to store the month. Then under the class calendar, there is a month interface. Class calendar, there is a method interface month. Okay, I can pass it as an argument to statement print. So these are some simple Python programs on Raspberry Pi. Now let us have a look at interfacing programs on Raspberry Pi. Means here let us see how we can interface external devices such as sensors, actuators, LEDs to Raspberry Pi computer. As a first program, you will see how we can interface LED light emitting diode to a Raspberry Pi computer. Okay, so components we require as usual Raspberry Pi computer, Raspberry Pi board, SD card loaded with Raspbian, monitor, HDMI cable, USB keyboard, USB mouse, power supply. Now, in this example, I am taking two LEDs, one a red and the other one is a blue color. Okay, I am trying to blink these two LEDs. I am making Raspberry Pi computer to blink these LEDs. So here I need two 1K ohm resistors. Okay, so to prevent excess current to be to prevent excess current being transmitted to LED, we are using 1K resistor. So I repeat, why 1K resistor? To prevent from excess current being transmitted to LED. So some jumper wires, some breadboard. So let us have a look at schematic diagram. Okay, see here I've used two LEDs. LED 1 is a blue colored and LED 2 is a red colored. Okay, see here for the what I've done in each of these two LEDs have two pins. One pin I need to ground. Okay, the other pin I need to connect to supply. Got it? Means the one pin of each of these two LEDs is grounded, whereas the other pin of these two LEDs will receive an input from Raspberry Pi. I repeat, the other pin, the longer pin, okay, of these two LEDs will receive an input from Raspberry Pi. Means input is whether to turn on or whether to turn off. Okay, since when this LEDs are passed an input, okay, some excess current might be transmitted, okay, might be supplied. So to prevent LEDs from getting damaged, okay, we'll use 1k ohm resistors. So resistor to oppose excess current. Clear? So now this is how we'll see. In this case, we have interfaced the longer line of LED1 and LED2 to GPIO numbers 17 and 27. So it means through GPIO 17 and 27, these two LEDs receives an input. I repeat, through GPIO pin 17 and 27, these two LEDs will receive an input from Raspberry Pi computer. Okay, I mean to say Raspberry Pi computer will control these two LEDs by passing an input, by sending an means it's an output from Raspberry Pi, but it's an input to LED. Okay, output from Raspberry Pi, but an input to LED. So I mean to say, while programming, I need to make configure these two pins GPIO number 17 and 27 as output pin. I repeat, the GPIO pin 17 and 27 of Raspberry Pi computer, I need to program configure as output pins. Okay. So let us have a look at program. Here I created two versions. The first version will just blink two LEDs, okay, and just blink two LEDs, one LED one at a time. Means totally LEDs will blink two times. Whereas the second version, the LEDs keeps blinking forever. Clear? So what I said first time, Raspberry Pi computer sends output through GPIO 17 and 27. This output is nothing but an input to LEDs. Okay, so first thing I need to configure this two pins as output pins. So for that, just have a look at the code fragment here. GPC, just have a look at this slide. There's a method set mode I have used. Okay, so set mode means set mode. Okay, here I'm setting this mode is used to configure the GPIO pins. See, and next what I've done, pin number 17 and pin number 27 I configured as output pins. Say for example, statement gpio.setup 17, gpio.out. It configures pin number as gpio 17. Okay, pin 17 as output pin. Similarly, gpio.setup 27 gpio.outs configures pin 27 as output pin. So now, okay, to turn on LED that is connected to pin 17, okay, just I need to pass I value, that is gpio.I to pin 17. Okay, so it will turn on LED 1. Similarly, to turn on LED 2, I need to pass I value to pin 27. Now both LEDs are on. Now let me have a delay of 1 second. Okay, time dot sleep of 1 means a delay of 1 second. Later, to turn off LEDs, okay, what I'll do, I will output a value low for pin 17 and 27. Just have a look in this slide. GPIO dot output 17, comma GPIO dot low. Similarly, GPIO dot output 27, comma GPIO dot low. Now, time dot sleep of 1 means 1 second delay. In the next version, okay, we are blinking LEDs forever. Means what to change any the code to turn on LEDs to turn on both LEDs by sending an I value, later calling for a delay, then turning off LEDs by sending low values, then calling for a delay. This should be repeated again and again. I repeat, turning on LEDs, calling delay, turning off LEDs, calling delay should be repeated. So I need to go for some looping. In this case, I have used while loop. The same program, but turning on LEDs, calling delay, turning off LEDs, calling delay. Repeated. So while one means true forever. So in this case, LEDs turn on off twice. Okay. I sorry. In the first version, LEDs turn on off twice, and in this second versions, it will keep turning on off forever. Now, let us have a look at interfacing buzzer to Raspberry Pi computer. Now, as usual, the components must and should require some components required. Okay, Raspberry Pi, SD card loaded with Raspbian, monitor, HDMI cable, USB keyboard, USB mouse, power supply. Now here I am interfacing buzzer, so I require buzzer and some jumper wires. So here there are two types of buzzers: active buzzer and passive buzzer. Passive buzzer means it emits a tone when a voltage is applied. It also requires a specific signal to generate a variety of tones. The active buzzers are a lot simpler to use. Okay, see, we can interface buzzer to Raspberry Pi computer like an LED. Okay, but buzzer doesn't require resistor. I repeat, we can interface buzzer to Raspberry Pi computer like an LED. Okay, but it doesn't require resistor. So let us have a look at the schematic. See here, this buzzer have two pins. One pin should be grounded and the other pin should be as an input pin to buzzer. Means while this input pin receives an I value, the buzzer beeps. When this input pin of buzzer receives a low value, it doesn't beep. Clear? So it's very simple, similar to previous program. Here, in this case, what I said, as you can see in the schematic, one pin of buzzer should be grounded. The other pin, in this case, it is connected to GPIO 17. Means through GPIO 17, Raspberry Pi computer sends signal to buzzer. Means it's an output from Raspberry Pi computer. Okay, output of Raspberry Pi computer is an input to buzzer. So this pin GPIO GPIO 17 of Raspberry Pi computer should be configured as output pin. Okay, one high value sent, buzzer beeps. One low value sent, buzzer doesn't beep. Let us have a look at code. See here. See, buzzer equal buzzer of 17. Okay, like I value here, I have from GPIO 0. Okay, we have imported a package buzzer. Under that package, we are using some methods buzzer dot on to send high signal, buzzer dot off to send low signal. See here, it's like in forever. Okay, while true means forever. What happens in this code? It beeps buzzer, calls a delay of 1 second, then doesn't beep, gets off, delay of 1 second, and after 1 second again the beep appears. Means it's forever. Means buzzer beeps and pause for a second and again beep until the program is terminated. Okay, buzzer beeps and pause for a second and again beep until the program is terminated. Now, let us have a look at interfacing passive infrared sensor. I mean, PIR sensor. It's a motion sensor. Okay, means to detect any movements. Motion sensor means to detect any movements. Got it. See, as usual, the components we require a Raspberry Pi computer. I mean, Raspberry Pi board. SD card loaded with Raspbian, monitor, HDMI cable, keyboard, that's USB keyboard, USB mouse, power supply. In this case, I'm interfacing PIR sensor, right? So I require PIR and jump OS. See, let us look at the schematic, okay? See, there are, and when you look at PIR sensor, there are 3 pins. Okay, one is ground, the other one is power supply, okay, and the other one is okay, it's colored orange. Okay, that's an output of PIR sensor. Let me tell you, the previous two programs, okay, we are dealt with input pin, okay, in buzzer and LED. Now here we are dealing with the output pin of PIR sensor. So let me tell you. In PIR sensor there are 3 pins. One is a black color as ground, red color as 5 volt supply. The orange color, okay, means here it's an input to Raspberry Pi. Input to Raspberry Pi means it's an output pin from PIR. It's an output pin from PIR, but output from PIR, but input to Raspberry Pi computer. I repeat, output from PIR, but input to Raspberry Pi computer. Okay. See here. Just have a look at the schematic. The output pin of PIR sensor, the output pin of PIR sensor, that is orange colored, is connected to GPIO 4. GPIO 4. Okay, I repeat, it is connected to GPIO 4. So GPIO 4, in this case, it is to be configured as an input. GPIO 4, in this case, it should be configured as an input. It's an input to Raspberry Pi computer. Okay, now what happens when the motion is detected by PIR? It sends a voltage. Okay, voltage will be sent, and that is received by GPIO4. Okay, clear. And based on that voltage level, Raspberry Pi can take action. See here in the file, okay, I've imported motion sensor package from GPIO 0. Then PIR equal motion sensor of 4 means here that pin number 4, okay, is an input pin in this case. So there's a method interface, okay, PIR dot motion underscore detected. If this is true, if the motion is detected, the okay condition is true, then we can perform what action we need to do. Okay, if say for example, let us display a message motion detected. To display a message motion detected, we need to go for print statement. Okay, so again it's we have used loop while true means this program runs forever until it is explicitly terminated. Okay, so every time the PI detects motion, we will see the message motion detected. Clear? So these are some three hardware programs. I mean interfacing programs. Okay, so in this session we add an introduction. I repeat, in this session we had an introduction to programming Raspberry Pi computer using Python. Next, we had a discussion about some simple Python programs. And also, we had a discussion about interfacing programs on Raspberry Pi computer. So, this is all about this session. Thank you for listening.